Hello friends, welcome to our channel. In this lecture, I would like to explain another example based on the Kanis method. See here, this is a portal frame, both ends fixed, and there will be an unsymmetrical loading, equal moment of inertia and equal heights of the column. See, this problem comes under the sway analysis. What are the conditions here to come this problem as a sway analysis means unsymmetrical loading. So this problem is sway because due to unsymmetrical loading. So generally what are the conditions of the sway analysis? Different end conditions. Means for example one end it will be fixed, another end will be simply supported. At the time also the frame leads to the sway analysis. Then unequal heights of the column. Heights of columns. For example this one will be A, B, C, D. See here both AB and CD, here it will be 4 and 4 meters. Sometimes AB equal to some 4 meters and CD will be equal to some 3 meters. So there difference in the heights of the column. At the time also the frame leads to the sway analysis. Then different moment of inertia for the columns. See here both AB and CD, here it will be I only. Sometimes you will get AB equal to I and AB equal to some 2I. At the time also the frame leads to be sway analysis. Then unsymmetrical loading. So here we are in this condition. So the loading is not symmetric. So on a 8 meter span BC, if the loading exactly acts at center, some 4 meters by 4 meters, so there will be symmetrical loading happening in this frame at that time. But here the loading is in eccentric manner, like some 3 meters by 5 meters. Then this type of frame leads sway due to the unsymmetrical loading. So we can solve this model by using Kanis method under sway analysis. So our first step is to find out the fixed moments. So already we solved so many examples based on the beams and non-sway analysis frames. So entire procedure will be same, but we have to remember that we can include displacement factor in the Kanis method. So our first step is to find fixed moments. So first find fixed moments for AB and BA. So there is no horizontal force is acting on column AB and CD. Therefore you will get fixed moments both M bar AB, M bar BA, M bar CD, M bar DC will be equal to 0. And what about M bar BC? M bar BC will be equal to minus WA into B square by L square. Here what is A? That is 3. And what is B? 5. By total span length will be 8. If you simplify this one, you will get the value is minus 187.5 in kilonewton meter. Similarly, M bar CB will be equal to plus WA square B by L square. So entire values will be same by 8 square. Simplify this value, you will get the value around 112.5 kilonewton meter. So after finding the fixed moments, your next step is to find the rotation factors for the Kanis method. Same like as continuous beams and non-sway analysis. But here you have to remember that you have to find displacement factors also, and that too only for the columns. Why? Because whenever sway happens, the frame will be like this. Means there will be B dash and C dash. So whatever the beam position 8 meters, it will be like this only. So there will be changes happening in the column. So the sway leads only to the column. So we have to find displacement factors for the vertical members, that is both AB and CD. So take down both rotation factors and displacement factors. So generally there will be two joints, that is B and C is the intermediate joint. So first take down joint and member, relative stiffness, sum of the relative stiffness which is denoted with sigma k, and rotation factor u equal to minus 1 by 2 k by sigma k. And your joint will be B and members are connecting members to the joint will be B and BC. And next joint will be C, connecting members to the joint C are CB and CD. Here you can observe that you are at B looking A. A is the fixed end. So if far end is fixed, your condition will be I by L. The relative stiffness will be I by L. And B looking C, for BC what happens? C is the intermediate joint which is considered as fixed one. So that is also I by L only. For example, if your A is simply supported end, then your BA will be 3 by 4 times of I by L. Already I solved this type of problems in moment distribution method also. So you please remember this one. Here B and C are the intermediate joints that is considered as fixed, and both A and D are fixed. Therefore your total relative stiffness for each and every member will be I by L only. I by L only. Then here for BC and CB they will given 2I. So therefore you can take your BC and CB will be 2I. Then you can add these two. What is I by L? I by 4. 2I by 8. So that is also I by 4 only. 2I by 8. Here also I by 4. And again you can add these two for sigma k. I by 4 plus I by 4. You will get 2I by 4 which is I by 2. And here also I by 2. Then U equal to minus 1 by 2 for BA, minus 1 by 2, where k value equal to I by 4 and sigma k value equal to I by 2. Again if you simplify this one, you will get minus 1 by 4. Like that you simplify each and every member. BC also I by 4, I by 2, minus 1 by 2. So here you will get for BC member it will be minus 1 by 4. Similarly for CB member also you can simplify in the same manner. Similarly for CD member also you can simplify in the same manner. After obtaining these rotation factors, then find the distribution factors here itself. Distribution factors which is denoted with the DF, and the formula for the distribution factor will be equal to minus 3 by 2 k by sigma k. And the distribution factors we are finding only for the vertical members, that is only for AB and CD. So already we know the value, just substitute in the formula, minus 3 by 2, k value will be equal to I by 4, sigma k value will be equal to I by 2. So simplify, you will get a displacement factor also, that is minus 3 by 4. Similarly, you can find displacement factor for CD. That one will be equal to minus 3 by 2. Your k value will be equal to I by 4 and sigma k value will be equal to I by 2. Finally, you will get the displacement factor for CD also equal to minus 3 by 4. Like that, you have to add extra column for displacement factors comparing to the non-sway analysis. So just you have to add displacement factors. Then our next step is to draw the Kanis diagram. Take down Kanis diagram. So I am taking one box for the displacement factors somewhere in between the columns on both sides. So this is fixed one, and take down the values A, which is AB here, AB, BA at B, BC, CB at C, and here it will be CD, D will be DC. So take down fixed movements. So that is AB will be equal to 0, BA also 0, and BC fixed moment will be minus 187.5 kilonewton meter, and CB fixed moment will be 112.5, and these two will be 0 and 0. So take down either inside or outside. Why? Because while calculation of rotation factors, rotation moments, it will be difficult. It will be aside means. Then take down rotation factors. Rotation factor BA will be equal to minus 1 by 4, and here minus 1 by 4, and here minus 1 by 4, and for CD also minus 1 by 4. And what about the displacement factors? It will be minus 3 by 4, and for DC displacement factor will be minus 3 by 4. So after writing all these things, next step is to find the balancing moment. So that is sigma MF for B. If you find the sigma balancing moment at B, what you have to do? You have to add both 2, that is BA plus BC, that is minus 187.5 plus 0 equal to minus 187.5. Similarly for C also, CB plus CD, that is 112.5 plus 0, that is 112.5. Like that you will get both displacement factors. So our next step is to solve this problem by using trials. So if you want to calculate, you can calculate directly by using the calculators, but it is better to check with some formula in the logical sense. So here I am going for the first trial, trial 1, rotation moments. So just like as non-sway analysis procedure only, but here we have to include rotation displacement factors also. So that is displacement contribution, displacement moment. So for trial 1, already I gave one formula to remember the procedure, that is if you want to calculate the rotation moment, that is mu into sum of the fixed moments plus sum of the foreign rotation moments. Here we have to add one more point extra, that is sum of the displacement contribution, means displacement moments. So I will tell you. So we know that already we solved so many problems, that is we are finding rotation movements only for the joints and connecting members, that is BA, BC and CB and CD. So rotation movements we are not calculating at the end moment, end positions, both here and for AB and DC. We are finding rotation moments only exactly at the joints, that is BA, BC, CB and CD. So therefore I am taking rotation moment for BA. So already I gave that formula. If you want BA rotation moments, multiply rotation factor for BA. Here rotation moment equal to MBA, U equal to minus 1 by 4. So already we find that balancing moment, which is sigma NF. For both BA and BC it will be minus 187.15, 187.5 plus sum of the foreign rotation moment. So you can observe clearly we are talking about joint B. For joint B, foreigners will be both C and A. For joint B, foreigners will be both C and A. But already I told you we are finding rotation movements only for the joint C and B, not A. Therefore, you will get foreign here only C. Here in the first trial, there will be no rotation movement at joint C, that is CB. Okay, if you are talking about both B and BC, only observe CB, not for CD. Why? Because CD is connecting member to the DC and CD, next member. But for B, connecting member will be both BC and BA. Therefore, we are looking both AB and CB, not CD. And one more thing, while observing joint C, joint B, your forend will be C and A, and connecting members will be CB and AB. But I already told you we are finding rotation movements only for joints, not for the end supports. Therefore, you can observe only joint CB. So here it will be 0 at CB. So your foreign fixed movements will be both AB and CB, but you are finding rotation movements only at the CB. So in the first trial it will be 0, there will be no value. Then sum of the displacement contribution. So you can see here displacement contributions are only finding for the columns, not for the beams. Why? Because already I told you, whenever sway happens, there will be difference in the columns, not in the beams. Therefore, you will get displacement contributions only for the columns, that is AB and DC. So while solving joint B, you can take displacement factors only AB column, not CD. While solving joint C, you can consider displacement contributions only for the column CD or DC, not for AB. Okay, but why we are talking about some of the displacement contributions? Means, so this is a single base, single story portal frame. Sometimes the questions will be like this. So the frame will be like this, and support to the first column. So this is joint B, joint A, this is joint C, D, E, F. Like that there will be one more column at joint B. So here what happens? Both B and C there will be no displacement factors. At these positions there will be no displacement factors. So here also if there will be one more extra beam also, you won't get any displacement factor. But if there will be one more first story column, at that time you will get displacement factors for this column also. At that time you have to consider both BF and BA displacement factors. So the summation indicates entire joint B displacement factors. So it will be two columns and two beams. Automatically beams displacement factors will be 0 here. If there will be one more story, means automatically you will get displacement factor for that story. But here the displacement factor is only for the one column. So there will be no one next story column connected to joint B. Therefore you will get only displacement contribution for the column AB here, and AB first trial there will be no displacement factor. Therefore here also you take that as 0. Okay, so you see that for the trial 2 you will get displacement contribution which we calculated in the trial 1. Therefore you observe clearly first 2 trials, automatically you will get the procedure how it will be. So if you simplify, what you will get, your M dash BA will be equal to, so it will be equal to 46.87. So whatever the value you are getting here, you can take directly 46.875. Similarly, go for BC. So if I am preferring BC, what happens? Rotation factor will be same. So you will get same value. If rotation factor will be different, you will get different value. You see in the formula as usually, rotation factor for BC will be equal to -4. Sum of the fixed movements will be equal to -187.5 plus sum of the foreign rotation movements. For BC already I told you, you can look CB. Okay, that is 0. And for B, what you will take? For BC, again displacement factors, we have to look in the beam connecting members columns. So there will be two members connecting to the BC joint, that is at B. So you can look only BA, not this CD. And I already told you, displacement factor for the beam always it will be 0. Therefore for BC also you will get same value, that is 0, which we are looking for the AB. So if you simplify, you will get the same value. Sometimes you will get symmetrical values only. Why? Because here loading condition is happening point load only, and there will be no loads acting on the columns. So immediately take down here 46.875. Then come to the C. So whenever you are looking for C, that is M dash CB. So M dash CB will be equal to, again take down displacement factors -1/4, and sum of the fixed moments will be equal to 112.5 plus here sum of the foreign rotation moments. For CB, foreign rotation means this is a joint C. For joint C, foreigns will be both B and D. So already I told you, at D there will be no rotation movements because of DC, but there will be rotation movements in BC member and BA member. If you look BA is too foreign to CB, but BC is foreign, that to near. That's why you have to look for CB only BC, not BA. And for CB you have to look DC also, but DC always it will be 0. Therefore you can take sum of the foreign fixed moments will be, one will be 46.875, another will be 0. So therefore I am taking 46.875, which was BC foreign rotation moment, plus, and sum of the displacement contribution. So you have to look displacement contribution in middle. For beam it will be 0. For CB you have to look DC column. Okay, and if there will be one more story means you have to look that one also, but there will be no first story column. Therefore you will get only CD displacement contribution, but in the first trial it will be 0. Here 0. Therefore I am taking 0, that is in the DC column, and simplify this one. If you simplify this one, how much you will get? You will get around minus 39.84. Minus 39.84. In the same way, you can go for next one, that is M dash CD. So for M dash CD also you can see here minus 1/4. Sum of the rotation factors will be equal to 112.5 plus foreign rotation movement for both CD and CB, it will be BC and DC only, but DC it will be 0. Therefore I am taking only BC, that is 46.875, that is BC, plus displacement contribution factor for CD will be both BC and DC. For DC it will be 0 because there will be no displacement factors in the beam portion, and for DC it will be 0 because for the first trial you won't get any displacement factors. If you simplify, again you will get same value. If your rotation factor will be different, automatically the values changes here. You won't get symmetrical values like this. Then After finding these rotation moments, your next step is to find the displacement factors both at AB and DC. See here, for story 1, displacement contributions means displacement moments. So for that, what you have to do means, if I am talking about AB displacement factors, displacement contribution for AB, that one will be equal to displacement factor into sum of the rotation moments for top and bottom of the columns. Bottom of the columns. So if you confusing means, you just take some of the rotation moments for top of the columns. So again, for AB, what I am taking here, AB rotation factor will be minus 3 by 4. So here I am taking AB rotation factor, displacement factor will be minus 3 by 4, and sum of the rotation factor for top and bottom of the columns means, you can observe. So this is the top of the column. So I am highlighting this one. This is the top of the column. That is both BA and CD. Don't look BC and CB. This is the beam portion. BC and CB columns are the beam portions. So only look BA and CD values. So we have to sum those two top of the columns. First point is sum of the rotation moments at top and bottom of the columns. You have to sum those two. That is 46.875 minus 39.84. That is your first point. Plus bottom of the columns means, you have to look in the bottom, AB and DC. Always AB and DC rotation moments will be 0. So therefore you will get 0 directly. So if you want, take down that values directly 0. This will be helpful in the next step. Why bottom of the column means, if you are talking about the second story, there will be one more frame, that is first story column. So at that time you will get so here you will get rotation movements both here and here. So at this time you can check, top of the column will be this one and bottom of the column will be below BC. But here this is first story column only. Always you will get bottom of the columns will be equal to 0. Therefore top and bottom of the columns will be equal to 0. So then simplify this one, you will get minus 3 by 4, 46.875 minus 39.84. So that one will be equal to around minus 5.27. Minus 5.27. So this is displacement contribution for AB. So immediately take down here, that is minus 5.27. Similarly, you find out displacement contribution for DC member. That is displacement contribution for DC will be equal to, again displacement factor for DC will be equal to minus 3 by 4, and again sum of the rotation moments for top and bottom of the column. So you will get same moments BA plus CD. So I will write down that value also here, BA and CD. So that is BA value will be equal to 46.875 minus 39.84, and bottom of the columns always 0 both at AB and CD. So why, already I told you this concept also. While solving multi-story frames, at the time bottom of the column, so always if you are in second story, you will get bottom of the columns will be first story, like that. But this is the single story, therefore you will get bottom of the columns will be equal to 0. And one more thing, what you have to remember means, while calculating the displacement factors, we are considering top and bottom of the columns both BA and CD. Why? Because while calculating displacement rotation moments, we are considering a related joint B to A only. But while calculating displacement factors, displacement contributions, we are taking both columns. Why? Because whenever sway leads, the columns tends to move like this. So this is the original position of the frame, and after sliding you will get like this: A, B dash, C dash, D dash. Means the displacement happens at a time both the frames. Therefore, while calculating displacement contribution, you can add both displacement rotation movements for the columns. So if you simplify, you will get the value here, that is same only. Because of the same displacement factors for both AB and DC, you will get same values. So I take very simple problems to explain the problem in a easy way. So next time you take some problem which is somewhat different, like displacement factors AB will be minus 1 by 2 and different like 3 by 4. At that time you will get different displacement contribution for both the columns. If possible, I will only solve in the channel. So these are the first trial displacement contributions and rotation moments. Similarly, we can move to the second trial displacement contributions. We will go for the second trial displacement contributions, and so I will explain this trial also step by step. After that you can solve the remaining trials based on this procedure, and immediately I will move to the final moments. So see here, trial 2 again displacement. So already I told you, rotation factor into sum of the fixed moments plus sum of the forend rotation moments plus sum of the displacement contributions. So I am at MBA. Already I told you, for B you can look CB and AB. AB will be 0. So rotation factor for BA will be first minus 1 by 4, write down that one. And some of the fixed moments will be inside value, which is minus 187.5, plus foreign rotation movement will be CB, which is first trial value, that is minus 39.84. Means this value, I am underlying this value, I am taking this value here, which was at CB. If you look AB, that will be 0. Okay, for joint B you can see both BA and CB. So I am taking foreign rotation movement will be minus 39.84 plus displacement contribution. For B you can look both AB and BC, not CD. Why? Because joint B connecting members will be both BA and BC. If it will be another beam or column connected, means you can take that distribution factors also. But always remember, beam's displacement factor will be 0. If it will be one more column connected, means you will get that displacement factor. Therefore you can take summation here. Otherwise just take for B only AB displacement factor, that is displacement contribution, that is minus 5.27. So for the second trial you will get first trial displacement contribution. If you go for third trial you will get second trial displacement contribution. If you go for fourth trial you will get a third trial displacement contribution. Like for each and every time, for first trial only you will get zeros initially. So remaining times you will get previous trials displacement contributions and displacement moments. So if you simplify this one, you will get how much the value will be. So it will be around 58.15 in kilonewton meter. So write down immediately here 58.15. Similarly, if you are preferring MBC, so you will get the same displacement factor, rotation factor, and again sum of the balancing moment will be equal to minus 187.5, and sum of the foreign rotation moments will be minus 39.84 and 0. So I am taking minus 39.84, and displacement contribution, one will be BA, another will be BC. It will be 0 always here for the beams, and BA it will be minus 5.27. So you will get same value, which is 58.15 kilonewton meter. So immediately I am taking here 58.15 kilonewton meter. Similarly, prefer M-CB. M-CB displacement factor, I am taking minus 1 by 4 because rotation factor into its displacement factor 112.5, minus foreign rotation movement will be, for C you can look DC and BC. So DC it will be 0. Therefore, I am taking only BC. That is next trial displacement factor. That is 58.15. And again, for C, you can look the displacement factor only for DC and connecting joint members. That is CB also. But CB it will be 0. For DC it will be minus 5.27. So already I am telling each and every time, if it will be connecting member and frame, you can add that displacement factors also. So if you simplify, how much you will get? You will get around minus 41.35 kilonewton meter. Similarly, you can write down minus 48.35. So due to same displacement rotation factors, you will get same value minus 1 by 4. Some of the moments will be 112.5 plus foreign rotation moments, which was at CB is 58.15. This is BC, this is also BC, and displacement contribution will be minus 5.27, which was at DC. So if you simplify, you will get minus 41.35. This is minus 41.35. Similarly, you can go for second story displacement contribution. Second story displacement contribution. So displacement contribution for AB equal to displacement factor into of the rotation movements for top and bottom of the columns. Like that you have to remember. Due to singly reinforced, you just take down some of the rotation movements only for the top of the columns. So no need to take bottom of the columns. Why? Because bottom of the columns always it will be 0. If it will be multi-story means automatically you will get bottom of the columns will be the first story while solving second story. So displacement factors for AB will be equal to minus 3 by 4. Sum of the top and bottom of the columns will be next value what you obtain. See here, the next value we obtained this one 58.15 and here 41.35 only for the columns. Don't look for beams. This is symmetry, the values will be same. If it will be unsymmetrical, like rotation factors will be different, means you will get different values. At that time your problem will be wrong. Okay, so I am taking 58.15 minus 41.35. So bottom of the columns always 0, therefore I am omitting here. So if you simplify, you will get minus 12.60. So immediately write down here minus 12.60. And again displacement contribution for DC or CD will be equal to minus 3 by 4, which was in CD displacement factor, top and bottom of the columns both BA and CD. So write down here for remembrance BA and CD, that is 58.15 minus 41.35. For this also both BA and CD. So if you simplify this one, you will get the same value, which is minus 12.60. That is minus 12.60. So this is the second trial procedure. Like that you have to solve trial 3, trial 4, trial 5. So how many trials you have to do means for how many trials you will get repeated values. For how many trials you will get repeated values. For example, if you will get repeated values in the third trial, you can stop up to there. If you will get repeated values in fourth trial, you will solve up to then. So remember one thing, while solving third trial, you will get second trial rotation moments and displacement factors. Like that you have to remember the procedure. So I will give the values directly, take down these values and do some repeated similar trials. So I will give the third trial displacement values will be around 60.36. So solve this one and take down. Solve by using the trials. This is 6.69. Similarly 6.72. Almost all you will get a repeated value here. Very near 6.629. So if you observe 58.15, 60.36, 60.69, 60.7, like that you are getting some near values. If you can go for next trial, you will get maybe some 60.7, which is the value very near, very close. So here also 60.36, 60.69. So solve this problem. Solve remaining 3 trials, 3 to 4 trials. You will get here 40.06 minus 39.49 and here also minus 39.49. 40 point, sorry, this one will be 40.06 minus 39.49 or 33. So already I stopped these two trials up to 5 5 and these two trials up to 4 4, but here I am getting near value, therefore I stopped this value and I take this value as the final value, that is 60.69. You also you can take the same value, you can stop up to some 3 to 4 trials. Okay, so here the values will be same, that is minus 39.49 minus 39.33. You can solve and check once whether it will be same or near. And displacement contribution will be, the values will be around for each and every trial you will get minus 15.22 for third trial, minus 15.90 and minus 16.5005. Similarly here also minus 15.22 minus 15.90 minus 16.05. So after, so you please leave some place for the bottom rotation moments also, always you will get 0 only, but don't take in line. So here these are the displacement contributions 5 and these are the rotation moments 5 for 5 trials. So you take down all these values, solve by using trials like this, so you will get these values, maybe some values approximately, not exactly these values, maybe some approximate values. After obtaining these values, then go for the final moments. So I will explain the final moments also. So that is also same like non-sway analysis, but maybe you can add extra displacement factors for the sway analysis problems. So what that I told you for the final moments. For final moments, so I gave the formula fixed moments plus 2 into near end rotation moments plus 1 into far end rotation moments plus displacement factors, displacement factor. See here I am talking about MAB. So if I am about MAB, check in the formula, fixed moment for MAB equal to 0 plus 2 into its near end rotation moments. Always AB rotation moments are 0 because we are calculating rotation moments only for the joints, plus 1 into far end rotation moments. So for AB, while solving the final moments, you always remember one thing, while solving AB your far end is BA, while solving BA your far end is AB. Okay, so 1 into far end, that is far end rotation movement will be recently what you will get. So that is the fifth trial value. So I am highlighting this one, observe here. So I am taking this value which is 60.72 plus displacement factors. So displacement factors can be taking only for the vertical members, that is AB and BA, not for BC and CB. Okay, by because the displacement sway happenings only in the columns, the variation only in the columns. Okay, so displacement factor that also observe only for the final value. There will be 5 trials where you are stopping at the 5th trial, therefore you can take that 5th trial displacement factor. So that is minus 16.05. Minus 16.05. So if you simplify, you will get a final value will be around 44.68 in kilonewton meter. So maybe you will get some 45 around. Then go for the BA. Go for the BA. So MBA. MBA fixed moment will be, here it will be 0. Here it will be 0. Plus 2 into its near end rotation. Near end rotation for BA is 60.72. Far end rotation for BA, already I told you, for BA far end will be AB. So while calculating final moments, you can check only that particular member, not for joint. For BA you will get CB also foreign, but don't take CB. Why? Because while calculating final moments B to A, you can check only with BA and AB. While calculating BC, you can check only with BC and CB. While calculating CD, you can check only with CD and DC. Not for C, it will be BC. Okay. And 1 into foreign rotation movement. Foreign rotation movements B, that is 0. Okay, that is 0. Minus, for BA, what is the displacement factor here? That is recently obtained value, that is minus 16.05. If you simplify, you will get 105.41 kilonewton meter. Then go for the BC member. So for member BC, again fixed moment plus 2 into near end rotation moments, that is near end rotation moment will be 60.72. For BC foreign is CB only, that is minus 39.49. Don't take displacement factor for the beam, that is BC. So for BC and CB displacement factor will be 0. Why? Because you won't get displacement factor for the BC and CB. So the displacement factors only happening in the vertical member. Therefore take down displacement contribution only for the displacement. So this is displacement contribution, sorry, not factor, displacement contribution. These are the displacement moments. So take down displacement contribution only here for the frame vertical members, not for the beams. So simplify this one, you will get around minus 1.541 kilonewton meter. Similarly MCB also. So sorry, here the fixed moment for MBC will be equal to minus 187.5. Okay, fixed moment for MCB will be equal to MBC will be equal to minus 187.5. Similarly fixed moment for MCB will be equal to 112.5 plus 2 into its near end rotation moment will be, its near end rotation moment will be this value, which is minus 39.49, and plus 1 into its foreign rotation moment. Its foreign rotation moment value will be the 60.72. Okay. Then what about displacement contribution? Displacement contribution will be 0 for the beam, that is BC, and if you simplify you will get the value around 94.57 kilonewton meter. And again MCD, MDC, MCD and MDC also similar. MCD fixed moment will be 0 plus 2 into its near end rotation moment will be minus 39.43. I'm taking this value minus 39.33 plus 1 into foreign rotation moment. So that was 0 for DC. Foreign for CD will be DC plus displacement contribution will be this recently obtained value, which is minus 16.05. Okay, take down minus 16.05. If you simplify, you will get around minus 94.57 kilonewton meter. Then MDC, 0 fixed moments plus 2 into its near end also 0 plus 1 into foreign rotation moment for DC will be minus 39.33, which was obtained in CB member, plus displacement contribution is minus 16.05. Okay. Then if you simplify, you will get minus 55.38 kilonewton meter. So this is only one story. If it will be two story means at that time also you can take summation of the displacement contribution. So if I am telling summation always means maybe it will be little bit confusion. Therefore I am taking displacement contribution directly for the single story frames. But you have to remember the concept. And finally observe one thing. After solving the problem, you check once sum of the moments at that particular joint B will be equal to 0. That is 1.5.41 minus 1.5.41. Here sum of the moments at joints will be equal to 0. That is 94.5, 94.5. Approximately it will get 0.1 error also, it will be 0 only. So these are the final moments. So based on this you can draw the bending moment diagram. So drawing bending moment diagram also very similar to the previous one. So like non-sway procedure. like same only. So I am taking that here MAB there will be 44.68 kilonewton, so which was acting clockwise here. So therefore I am taking clockwise moment. The beam will be, whenever a force is acting like this, so there is a chances of moving up to here like this. So like in the logical sense I am solving the bending moment diagram. And you can see here MBA, it will be 105.4 kilonewton, so it will be around 105 means. So here the beam will be like this. So whenever an external force is acting it like this, it can move like this, like that. I am telling, if an force will be acting, it will be somewhat up to some 105 unit, that is 105.41. So draw the lines. Okay, similarly talking about BC column, BC column there will be another movement which is BC will be equal to like this, and CB also will be equal to like this. So there will be anti-clockwise rotation which is acting minus 1.5. So here it will, you will get like this, and there will be clockwise rotation, you will get 94 like this, and you can add these two. So this is 105 and this is some 94.5 around 105.4. In the same sense you will get anti-clockwise rotation in column CD which is 94.85, and minus anti-clockwise rotation in column which is 55.38 in DC. So you can add these two also, like that you will get a bending moment diagram. And automatically we know that whenever an eccentric load is acting exactly at the point load, you will get a triangular variation. And you can find out this maximum bending moment, you can find out this maximum bending moment by using WAB by L, it will be around some 300. So exactly you can remove the ordinate point, so find out the ordinate point exactly for this 3 meter span. So already I solved so many net bending moment values for the previous problems, you check once, you will get the net bending moment, how to solve the net bending moment values also. So I hope you understand this lecture.